Hello and a very warm welcome to everyone joining us for today's Select Science webinar titled Redefine Volatile and Semi-Volatile Organic Compounds Analysis by GCMS from start to finish. My name is Carrie Haslam and I'll be moderating today's presentation. I'm delighted to be joined by our guest speakers, Yoshihiro Hiramatsu, GCMS Product Liaison, and Dr. Ruth Marfil-Vega, Senior Markets Manager at Shimadzu Scientific Instruments, as they explore how their latest GCMS instruments, in combination with the multi-platform software Lab Solutions and Lab Solutions Insight, enable successful detection, quantitation and suspect screening of volatile and semi-volatile organic compounds. Please feel free to submit any questions you may have during the webinar today. To do this, simply head to the engagement window to the right of the auditorium and click to open the Q&A window. So without further delay, I'm delighted to hand over to our speakers and would like to thank them for presenting with us today. Please go ahead.
Thank you for the introduction and welcome all to the webinar where we are going to learn how new technology can help us with redefining environmental analysis by gas chromatography mass spectrometry. Let's get started because we have a really packed program today. When we talk about environmental contaminants and their analysis, we need to remember that the samples go through several steps until we get to the point where we measure the concentration of the specific contaminants. Today, Yoshihiro and I are going to talk about the instrumental portion of the workflow I'm showing in the slide, specifically the sample analysis and the data reporting steps. And even more specifically about the methods relying on gas chromatography mass spectrometry analysis, or GCMS. So why are we highlighting GCMS today? Because historically GCMS has been the most used instrument for the analysis of environmental organic contaminants. EPA approved many methods over several decades relying on this technology. So Yoshihiro, can you tell us a little bit more about the history of Shimadzu in relationship to GCMS instruments?
Thank you for explaining about environmental application workflow. I try to explain about GCMS history in Shimadzu. Shimadzu have developed and supported GCMS for over 50 years since 1970. GCMS 9000 is magnetic sector MS, and this is the first GCMS in Shimadzu. From then, we are investigating all technology, including hardware, software, and application until now. This new GCMS QP2050 is the latest instrument, and we pack our cutting-edge technology. This is some brochure picture. It's so nice. It's so cool. This newest GCMS QP2050 was launched in early 2024. Incorporating some latest technology to help laboratories redefine their GCMS workflows. So Ruth, what are the main roadblocks environmental labs face when doing a GCMS analysis?
In general, every type of environmental lab is going to look at improving the lab throughput. Constraints might be different, or priorities. Big commercial labs may have the need of reporting results as fast as possible to the clients. Mid-sized utilities might be facing challenges because they cannot replace quickly technicians that are retiring after long tenure in the laboratory. Or academic labs would like to have the students writing more papers and proposals instead of spending time fixing instruments. Overall, they face three bottlenecks that prevent the increase in the throughput. limited analytical capacity for data acquisition, spending lots of time processing, reviewing, and reporting data, and spending also a lot of time taking care of instruments that might not be working. So Yoshiro, let's start with the first point. What are your suggestions for improving the analytical capacity for the data acquisition and how the Shimadzu GC-MS QP 2050 can help with that?
I see. Luz. So analysis throughput is one pain point to increase the productivity. I come up with two ideas. One is increasing instrument number in laboratory, and the other is less time for one injection. Instruments per laboratory multiples injection per specific time frame will be directly affect to laboratory output. Simple way to increase number of instruments is expand your laboratory area or building. However, it costs a lot and take much time to construct building and prepare for all facilities. So that we need to consider about how to use existing laboratory area more efficiently is some key point to enhance laboratory productivity quickly. So far, conventional GC-MS system occupied one table to put on GC-MS and also control PC and monitor next to the GC-MS system. However, brand new GC-MS QP 2050 with previous GC 2050 can install the two GC-MS systems on one table without any customize. GC-MS width is totally 630 mm. This size achieves more capability in laboratory. And the PC controls some two GC-MS system via Ethernet cable, so you don't need to put onto the PC next to the instrument. Due to technology improvement, GC and MS, both of them are getting smaller and smaller. And as a result, we can put two instruments on a table, which we can put on one GC-MS system so far. Let's see how it improves. When we install new GC-MS as successor of the old instrument, of course, we can get exactly same application using the latest GC-MS. Once we install one more GC-MS, addition to successor, we can double injections for samples. In this case, we can use same calibration standards, same SOPs to run the second instrument. So without any additional resource, we can achieve a double productivity using a latest GC-MS system, such using some very small footprint GC-MS system. Even if you decided to run different application on second instrument, it will expand laboratory application capability and make more productivity. For example, one instrument is for semi-volatile to take over all the instrument, and second instrument will be used for microplastic or test and odor or other applications. So latest GC-MS technology support to use existing laboratory area more efficiently and give more productivity and capability for the laboratory.
Thank you, Yoshiro. Can you elaborate now a little bit more on your second idea, the increase of number of injections in a given time?
Yes, Ruth. We have several ideas to achieve a faster method using some GC-MS. One is set higher oven-lamp ratio to drive our compound as much as possible. In that method, we need to revalidate chromatogram separation and other things will be needed. Second one is change carrier gas from helium to hydrogen. In the theoretical plate, we can get good separation even using a faster linear velocity using a hydrogen. It means that method will be shortened with a good chromatography separation. However, in this case, hydrogen is not inert gas and need to check all target compounds don't affect from the hydrogen. Some methods for compliance analysis have strict requirements and alternative gases cannot be used. Last one is using a shorter column. This is what I want to talk in this webinar. When we can use a shorter column with same theoretical plate, we can keep the same chromatography separation without any development. And also we can keep using a helium, not to worry about interaction between the target and the carrier gas. So this is a comparison example between the 30-meter column and 20-meter column TIC using the same type of column with some same theoretical plate. We use a typical 8-70 semivolatile method with 8-70 standard mix, which includes 8-70 megamix and benzidine, 1,4-dioxane, and benzoic acid, and other compounds. 30-meter column result meet all the requirements for the 8-70 method. It means that DCMS QP2050 is able to run the semi-volatile application following a method with 30-meter column. After evaluating instrument and method, we translate method from 30-meter to 20-meter using a LESDEC method translator and line it. In the result of the 20-meter column, we can finish GC runtime within the 11 minutes, which take time 22 minutes with conventional column method. It shows that we can run almost double sample in one instrument. However, what should we take care about method development using such a faster method, addition to some GC open ramp ratio? First point is column capacity. When we use the same injection volume and same split ratio for narrow bore column capacity is big differences between them. Left chromatogram is 30-meter result of benzo-A-pyridine and it is so good. But middle of chromatogram, which used for narrow bore column with same injection volume, is not good result, because injection volume is over the column capacity, so that chromatograph is leading. Of course, we can use this method as long as passing the method criteria. However, it is not perfect. To get a beautiful chromatograph like a 30-meter column result, we can reduce the amount of compound into column by increasing the split ratio or decreasing injection volume itself, like a 1 microliter injection to 0.5 microinjection. In this example, we can get a clean chromatograph using a higher split ratio than 30-meter column injection volume. So to get a comparable chromatography using a narrow bore column and a conventional column, sometimes we need to reduce the injection volume into the column. It means that instrument need a higher sensitivity than conventional instrument. Point to take care using a faster method is peak points. It means that scan rate. Fast method compress everything in short time, so peaks will be a sharper and poor chromatography if we use same scan rate with conventional method. As theoretical side, 8 to 12 points for one chromatograph is needed to get enough reproductivity. For example, this is 1,2-dichlorobenzene peak using a several conditions. The left side is a 30-meter column with some 0.25 mil in the diameter. It consists 10 points to create some one compound peak. However, the middle peak scan speed is same with 30-meter column, but chromatography doesn't have enough points because of the sharper peak. So it consists only the 6 points and looks like slightly zigzag. At that time, we set more scan rate. It means that faster scan rate for faster method. As a result, we can get enough points for chromatogram with faster method, like a light one. So light drawing, we set some double scan speed than the some 30-meter column, and it achieved a good chromatography even we use a faster method. So use faster method with narrower column. There are 2 points to develop method. How to contribute by latest cutting-edge GCMS technology. To keep sensitivity between conventional method and faster method, high-sensitive instruments are required because we need to reduce injection volume due to column capacity. Our new Dura-Ease ion source, which in GCMS QP2050 can get higher sensitivity than conventional ion source because optimized ion source design to generate more ions and transfer ion into quadrupole with minimum losses. Even injection volume is getting less, we can keep the sensitivity using this ion source. Let's see some example. This is the experimental result using the same mixture with 30-meter application. Standard consists megamix and benzidine, 1,4-dioxane and benzoic acid, and other compounds. We translate GC oven method from 30-meter on column method and set a faster scan speed and higher split ratio than the some 30-meter column method to use the some narrow-bore column. So runtime is 11 minutes. It's very faster than some conventional column method. For example, I choose an NDMA from early volatile compounds. We can match a 870E initial calibration criteria and get a good calibration curve from 0.05 ppm to 10 ppm on the vial. Regarding later added compounds, you can see good chromatograph for benzo B and K fluorantane. We can get a good peak shape and good calibration from 0.05 ppm to 10 ppm and meet all the requirement for the 870E method running. Adding to the calibration and chromatograph, benzo B and K fluorantane or such isomer combinations are needed to check resolution between them. In this result, we can get enough separation for those isomers. It is approximately 10% resolution. So even using a higher split ratio, we can meet a semi-volatile method requirement using a QP2050. So let's see the scan rate. So we need to use a faster scan speed to keep enough point for compressed peak. GCMS QP2050 equipped a new quadrupole and RF power supply. It achieved ultra-fast scan performance without sacrificing accuracy. Before going to see experimental study of some ultra-fast scan analysis, just refresh analysis mode using a single cut MS. So far, scan mode is common approach to run the qualitative and quantitative analysis. However, SIM, selected ion monitoring, is getting common approach in several environmental methods. Scan results include all the information from the sample, but easy to affect from the matrix or contaminant, so that some sensitivity is so-so. On the other hand, SIM is suitable for quantitative analysis, and it shows 2 or 5 times lower reporting limit than scan analysis. So some applications use a SIM approach to do routine sample analysis. However, sometimes we need to report qualitative result for unknown compounds. At that time, like a light drawing, scan and SIM, simultaneous analysis is a powerful approach to achieve both requirements, qualitative report use scan result, and quantitative report use SIM result. These years, GCMS can do that, and scan and SIM simultaneous approach is getting common. Let's see ultrafast scan rate study. We prepared several conditions. One is common range and speed around 1000 U per sec. One is faster scan speed around 10,000 U per sec. And the last one is a scan and SIM with around 4,000 U per sec. As a result of the similarity score comparison, we cannot see any differences between those method results. Even using a faster scan speed or scan SIM simultaneous analysis, library similarity score, library search result is same between all the methods. Right graph shows all similarity score of compounds. Some of them shows lower value because of the co-elution compounds. However, almost all compounds shows great result. Co-elute compounds are not good show the in addition to reduce the wine injection time, keep running instrument with EPA requirement is also important. This is experimental study for Persian trap GCMS system. For BFV check, we can run without any maintenance over the 800 standards and the sample injection in 25 sequences. We stopped this study over 800 injection, but it still passes. We gave up to continue it. So use good pattern adjustment algorithm to meet the EPA requirement. Makes running instrument without a stop. This is also important to analyze throughput. There are ideas to increase analysis throughput using a cutting-edge GCMS technology. How is it good, Luz?
Yoshiro, you shared great info. Let me recap it for our listeners. Main two ways to improve analytical capacity for data acquisition is 1. Increasing the number of instruments in your lab, either by expanding your lab space or using smaller instruments. The second option is to increase the number of samples you can run in a specific time. You can achieve that, but by running faster methods, and you show us how using shorter columns it's a perfect solution for that. And also you mentioned about the use of robust GCMSs, so you don't need to spend so much time on maintenance, and you can keep on running samples. And the Shimadzu GCMS QP 2050 addresses all those 4 main areas for improvement on analytical capacity. Let's move now to the next bottleneck, laboratories phase, to improve throughput in the lab, the data management and its individual tasks, data processing, review, output that goes together with the final reporting. Yoshiro, how the latest technology in GCMS and software can accelerate this data management process?
Okay, Luz. So let me introduce latest processing software and how it works in routine environmental processing workflow. LabSolutions Insight is our latest routine processing software, especially for the MS. Once we open the batch, we can see all the information at once. So top side, we have a sample table and a compound table like this. And every time you choose some specific compound or sample, the bottom side is simultaneously update each result. So bottom left side, we can see the mass chromogram of the target and also the ISTD, internal standard result at once. And the middle of the bottom side, we can see the spectrum pattern. Top is some actual result, and the bottom is the standard spectrum from the library or the high concentration result. On the bottom of the right side, we can see the calibration curve like this. As first step to do the data processing after running an instrument, we need to check the initial calibration result is okay or not. At that time, you can do integration one by one, but I recommend to use some focusing function using a flag. So if you set up the flag for some standard for the initial calibration, we have several options to set up some parameter to identify that initial calibration is passed or not. In method, usually we submit some accuracy of each point and some RF percent RSD of the curve so that we set up those component in the flag. Especially for some internal standard and surrogate is not applied that requirement, so we delete those results in here, the flag. And in the result of, if something wrong, we apply to all the flag as some fail flag in here and apply it. So you can see everything passing for some level 1 to 7. But when we check the flag ID, something wrong in the level 8. So we can see some flagging blue and red color. It means that some of the accuracy is failing and RF percent RSD of the some calibration curve is failing as well. So let's see what is happening on the 1122 tetrachloroethane in this result. We opened the survey and checked all the chromatograph at once, and colored and this target compound is focusing by the color because it is flagged. So let's see this one. So the peak integration is wrong, so that the accuracy of this point and also the calibration curve is fail. So let's fix it. So the processing of table is slightly shifted, is wrong from the correct retention time. So we can update that compounds, update the retention time and the ion ratio like this. So once we update from some current existing result, it show up some correct processing result for sure. Let's see. So there is no flag ID for all the initial calibration curve result, and the double check the chromatograph is correctly identified or not like this. So 1122 tetrachloroethane, yes, here, and everything is good. Identification and also the integration as well. So once initial calibration is passed, meet the criteria of the method, we need to double check the some continuous calibration curve result for sure. So let's go to the some continuous calibration side. So when we choose the some continuous calibration check compounds as some CC sample type, we can start some data processing for the some continuous calibration. Depend on the what kind of processing you want to use, we can save the some layout of the some table setting or the some windows. And for the CC, we don't need to create every time to the some flags for the some continuous calibration check, initial calibration check, or something like that. We just load the some existing flag for the CCB and check the some CCB is passed, fail, or not. So in here, we already put into all the target is within the some 20% accuracy. And also ISTD should be within the certain range, and also surrogate recovery Once it's applied, everything passing, so it means that we can inject a standard real-world sample finally. Let's see how to process some real-world sample using some lab solutions inside. So we calibrate some instrument and we pass some continuous calibration so that we will process some unknown samples. Of course, we can prepare the unknown samples template of some processing and apply to the flag because there is some several criteria for internal standard and recovery ratio so that we apply to that, it pass, and the sort of some unknown compounds like this. Let's see. So surrogate ISTD pass some requirement for the method so that let's see some target compounds in the table. So sort the target compounds and see the and sort the area count, and we can see the what compound is detected and what concentration it is. Some of the compounds show some slightly different spectrum pattern from the library. It means that it is contamination, so that we can delete those peaks one by one. Yes, that is some routine workflow for the environmental quant analysis, like processing, reviewing, adjust the integration parameters, and that is some routine process. So how to contribute the latest GCMS technology to this routine work? So there is some conventional parameter to integrate some peak. For example, slope or something like that. So baseline processing may vary by operator. So we use some slope, width, minimum area or something like that, and need to adjust all the parameter for each compounds. And as a result, we can get the expert integration like this one. These years, artificial intelligence, we call it AI, is hot topic in the world. ChatGPT, OutDrive, healthcare, all technology in the world implement AI technology. It is same in the data processing world. New processing software has AI-assisted peak integration, which can develop using a machine learning. So far, we need to set peak integration parameter like slope, width, but this AI-assisted peak integration doesn't have those parameters. They learn from education dataset, so no need to parameter at all. This is an example for peak integration using an AI-assisted. Right one is manual peak integration by experienced operator. It's expert integration. Left one is AI-assisted result. We can see comparable result with expert integration and peak intelligence AI-assisted integration. To use those latest techniques, we can completely reduce the number of the manual integration results, and it means that speed up the post-processing for sure. So once you data process all the data set, you need to report the result. So of course, this lab solutions inside already prepared for the report template for some basic environmental report. For example, when we want to create an initial calibration curve, you choose some calibration curve report template and open it. This is the preview, and you can see all the required information: sample name, data file, area, and concentration, and the accuracy of each point, and the RF percent RSD of the curve. And once you put the print, it report as some PDF or actual printer or whatever you want. Once you learn some initial calibration report, next will be unknown compound report, unknown sample report. So you check the samples and report it, and there is some unknown sample report in here in the lab solutions inside. So you can see the internal standard and the surrogate, and there is some criteria of each ISTD and surrogate, and also report some target compounds like this. And if it's okay, you can report it.
Let's recap the information you shared, Yoshiro. With the videos and the additional details, you show us how intuitive and multi-platform software accelerates the steps included in data management. Also, you talk about the benefits from modern analytical intelligence-based algorithms that help with better integration of the peaks. With the review by exception and customizable flags, it's very easy to review the data according to EPA QA criteria or the other criteria that each lab might be interested in. And last, with the customizable data output and the preset reports, labs need to spend less time thinking and preparing for the final reporting. And as you mentioned, everything can be done with lab solutions inside. And now, Yoshiro, the last topic. Downtime in the lab cannot be avoided. The same way you need to stop to put gas on your car or charge the battery if you have an electric vehicle. So how is the new technology in GCMS helping us with minimizing downtime?
Thank you, Luis. Yes, definitely minimize the downtime is important to enhance the laboratory output. When I characterize the downtime, this is my thought process. So reduce the maintenance frequency and also reduce the time for the one maintenance time. Addition to that, reduce the human error is also very important to minimize the downtime. So let's see one by one. So let's see the reduce the maintenance frequency. So in the brand new GCMS QP2050, we equip some Dura-is ion source. So Dura means some durability, and this type of the ion source keeps some good sensitivity without some maintenance, a lot of maintenance frequency. And also, Shimazu quadrupole rods equipped some pre-load before the some main load. Those pre-loads protect the main load from the contamination and keep the some quadrupole clean. Those both technique combination, it extended stability without the need of the source or MS maintenance. For example, we inject a 500 consecutive analysis, water analysis for the VOC, but even the absolute value, absolute intensity, it is very consistent, and also repeatability is pretty good. Okay, let's see the some Dura-is ion source side. So there is only 3 steps, 2 tools, and 1 minute exchange for the some brand new GCMS Dura-is ion source. Let's check it. So you just open the door of the in front of the some MS instrument, put into the jig to combine the some lens and the box, and you just loosen the 2 screw and took it out. That's it. If you have some extra ion source set, you just put in some brand new maintenance ion source instead of the old one, and tighten the 2 screw, and remove some tools. That's it. It's completed within the 1 minute. Addition to that, ion source structure is getting very simple. It means that the parts of pieces of the ion source assemble is getting less, and the number of the tools is getting less, and also reduce some assemble and reassemble time from 10 minutes to 1 minute. The thanks for the some effort of the manufacturing and the simplified design, we can manufacture that ion box and also repair at much cheaper than before. So we can handle those components as a disposable consumables if the lab manager won't. It means new waste. However, we don't need to clean up using some solvent and the flask and something like that. So it protect those type of operation, protect some chemist or operator from the solvent expose. So far, I introduced how some latest technology reduce the maintenance frequency and also reduce the time of each maintenance. However, I truly want to reduce a human error as well. Why human error is happen is because complicated to remember everything for the maintenance or difficult to reach out some instructions. From Shimazu and Shimazu scientific instrument, we can prepare some YouTube video to remind you how to do some maintenance on our ZC or ZCMS system. And also, we prepared some maintenance help guide for your cell phone. So if you jump using this QR code, you can see all our ZC and GCMS maintenance guide on your cell phone. So even you forget how to do that, you can remind easily using your device.
So brief summary of what you mentioned. If we want to minimize downtime, we need to be decreasing the frequency of maintenance, the time we spend doing the maintenance, and minimize the human error. And we can achieve that using the Shimadzu QP 2050, since it's a robust GCMS that has built in the latest technology, and it's been designed keeping the user in mind. Let's go back to the beginning of the webinar. We wanted to show you how newest technology can help you redefine your environmental analysis by improving analytical capacity for data acquisition, accelerating your data management, and minimizing downtime. We shared with you this matrix of parameters and actions that can help you addressing each of the main topics mentioned in the last slide. As Yoshiro explained in detail during the webinar, the GCMS QP 2050 can help you increasing the number of instruments in the lab, increasing the number of injections you can run, decreasing maintenance frequency and the time you spend, as well as making it easier for the analysts to don't make mistakes. And together with Lab Solutions Insight and the newest algorithm, Peak Intelligence, the GCMS QP 2050 will help you also redefining the data management process.
Yes, the brand new GCMS QP 2050 definitely contribute to increase your laboratory output for sure. If you want to see more detail, please check our website.
Thank you, Yoshiro, for all the information you shared with us today, and thank you everyone for listening. If you have any questions about the QP 2050 or any of the other solutions that Shimadzu offers for environmental analysis, don't hesitate to contact us. Also, you can visit the different accounts in social media that are listed in the screen. Thank you, everyone.
Thank you to our speakers for that interesting presentation. I hope that everyone listening enjoyed the webinar and found it informative. So we'll now move on to the last part of today's webinar, which is the question and answer session. So the first question we've got here is, how did Shimadzu engineer the QP 2050 in such a small size?
Oh, thank you. I will respond to that questions. Actually, I'm very happy to announce why some brand new DCMS is so small, because I was joined in the engineering team so far. So the main reason is that the electronic components are minimized, and also the number of some electronic boards is less than some conventional DCMS systems. So due to some such technology improvement, we can achieve some such a small footprint on DCM single quad. Addition to that, brand new DC 2050 combined with some DC 2050, we can achieve a very, very small footprint DCMS QP 2050. Yeah, that's some answer. Yeah.
That's great, thank you. So we've got another question here, and this is one for Ruth, and it's, which environmental applications can be run with the QP 2050?
Well, as people listen during the webinar, we can run volatiles analysis, semi-volatile analysis, but the reality is like every traditional environmental application can be done in this instrument. We can do taste and other compounds, one for dioxane, nitrosamines, you name it. And also you can use it for more emerging applications, like the analysis of PER and polyfluoroalkyl substances, or PFAS, as well as microplastics.
That's perfect, thank you. So another question here is this data processing SW mentioned in the webinar used for other instruments like GCMS MS or LCMS MS?
Yes, definitely. The lab solutions insight which I introduced in the webinar is especially for MS data processing software. So you can use not only the DC single quad, but the DC MS triple quad or LCMS MS analysis. You can use some lab solutions inside some data processing software. Additionally, Lab Solutions platform is used for the operating all the Shimadzu instrument, not only the MS, but LC, GC, and the other TOC or some other instrument can be used by the controlled by the Lab Solutions platform.
Ion chromatography also.
Ion, yes.
Perfect, thank you. So another question here is, in the presentation you mentioned ion source can be used as disposable. Does that mean it can't be polished and used?
Yeah, actually, we can really use some ion source with a conventional maintenance way, like scrubbing some surface and the sonication and some bake out and put it back. So depend on some your laboratory's workflow, you can choose, you can use as it disposable or reuse it.
Yeah, if you like to spend time cleaning, you can still clean it.
Perfect, thank you. So we've got another question, and this one is, can we export results from Lab Solutions as a CSV file to connect LIMS system?
Yeah, this is good questions. I explained about some reporting using our Lab Solutions inside, but in addition to that, we can export a raw data from the actual data as a text file. And also, we can export some CSV format from the Lab Solutions inside as a processed data set.
That's great, thank you. Another one here is, if I need to troubleshoot my instrument or method, how can Shimadzu's team help me?
I'll take that one.
Yeah.
If you want to troubleshoot your system, my recommendation would be to reach out to your local team And the best way to kickstart the process and make it as fast and as smooth as possible is by sending by email one data file to your local support team. And the reason why this is fast is because in Shimadzu's files, you can, or we can find tuning information, the status of the instrument, and the method. So let me correct my answer for a second. We need two files. One from when the instrument you think was working fine, the instrument or the application was performing as it should, and one file from after you notice that there are some problems. So with those two files, the before and after, we have everything that is needed to kickstart the process.
That's perfect, thank you. So this one is, following on from troubleshooting, do you have any tips or suggestions on how to accelerate method update after doing maintenance, like changing or cutting the GC column?
I will take one. So we have Shimazu have a nice function about the method management, about updating a retention time. So we call it AART, Automated Adjusted Retention Time. So once we inject N alkanes mixture after new column installation or the trimming the column, we can update all the retention indices at once using N alkanes result. So you don't need to update the retention time one by one, or the several standards to adjust some retention time.
That's great, thank you. So we've got this one here, which is, when I use my current GCMS non-Shimadzu to acquire data using SIM, SIM, and scan, two files are created. Does simultaneous scan/sim also generate two files?
Actually, no. In Shimazu instrument, the one data consists all the information, both scan and SIM. And in case of scan or MRM, we can save all the data set into the one file, so you can see all the information from the one data.
That's great, thank you. This one is, does EPA method allow to use the narrow bore column?
I'll take that one.
Yeah.
Yes, the short answer to that is yes. EPA methods include a section about flexibility, depending on whether the methods are for drinking water or wastewater or other samples. The degree of flexibility is more or less. But as long as the change of the column is included in that flexibility, you can also change other parameters within that flexibility that is allowed in a specific method. And the most important thing is to make sure that the performance is met. So if you change your column, you are going to have to demonstrate again that you meet the QA parameters that are listed in the method.
That's great. Thank you, Ruth. So we've got time for one more question here, and this is, the webinar is focused on GC-SQ. Are there any EPA approved methods for using GC-TQ?
I'll take the last one also. Yes, we focus today on single quadrupole, but there is one method, actually two methods that have been approved by EPA to use GC triple quadrupoles for a long time. They are 8260D as in David and 8270E as in elephant. Those have been approved for several years and allow you to use either single quad or triple quadrupole. Recently, also EPA approved a new method for the analysis of dioxins, and that was actually Shimadzu provided one of the alternative testing protocols for the analysis of dioxins by GC triple quadrupole. And those alternative testing protocols made it or accelerated the approval of the new method that is an alternative for 1613B that uses magnetic sectors.
That's great, thank you. Well, that's all we've got time for today. So thank you to our speakers for today's discussion and presentation. And thank you to everyone joining us online and for sending in your question. We hope that you found this a worthwhile session. If we didn't quite get to your question today, we will follow up with answers to these after the webinar. And if you've got any other questions, please feel free to email me at editor@selectscience.net. If you're interested in receiving a certificate of attendance, this will be shared with everyone who has attended live today via email a few days after the event. And if you would like to listen again to today's webinar or invite a friend to listen, it will be available to watch on demand in just a few days' time. Goodbye and thank you once again for joining us.